Okay, so for this next question, we have an EM wave that has an electric component given by this equation. E equals 8.26 millivolts per meter, sine 3.85 by 10 to the 6 y minus 1.16 times 10 to the 15 t. Part A, what is the value of B max in picoteslas? Okay, so the formula that we have to use to work this out is C equals E divided by B. Now, from our equation, we have E max. It's at 8.26 millivolts per meter. So, therefore, B max is going to be given by E max divided by C. And when we do that, we get 27.53 times 10 to the minus 12 Teslas, which is 3 significant figures. So 27.5 picoteslas. So that's the answer to part A. Part B. Which term below best describes this wave? Radio, microwave, infrared, visible, UV, gamma, X-ray, gamma is there twice. I'll fix that up. Okay, so which of these best describes it? Well, a good way to work this out is either we need to know what either the frequency or the wavelength of the wave is. So let's just do wavelength. So wavelength is related to k by 2 pi divided by lambda. Therefore, lambda is 2 pi divided by k. Now, our k in this instance is our 3.85 times 10 to the 6. And when we do that, we get 1.63 times 10 to the minus 6 meters, which is 1.63 micrometers. This wave with this wavelength of light, it's going to be an infrared wave. And part C, if the electric component of the wave is described by the unit vector j and the magnetic component is described by the unit vector I, what is the direction of propagation of the wave? So remember, we have to do our cross, we do E cross B to work out the direction. So we have our I, our J, and our K. So we have the electric component has J, so we point our fingers in this direction and we have to curl towards the magnetic component. So we're curling in this direction. And when you do that, you realize that your thumb is pointing towards the negative, towards negative K. So therefore, negative Z is the answer. And that's how you do that question.